Hey, hello, folks. Welcome to this week's long range weather outlook, where we will review what the weather is going to look like over the next couple of quarters. This is our bi-weekly webinar, and I'm Dr. Hansi Singh, and I'm excited to get started. First, a quick introduction to myself. I am the founder and CEO of Planette AI. I am an Earth Systems scientist. I also used to be a fellow at the US Department of Energy. Hi, Dominic. I used to be a professor. I'm currently still involved in research and development for Earth system models through the CESM working groups at the National Center for Atmospheric Research in Boulder, Colorado. So let's get into the long range weather outlook. What I'm going to do first is start off with how long range weather forecasting works and how it is different and distinct from near term forecasting. Then I'll get into some of the fundamentals. Particularly, I'll talk a bit about modes of variability and where they stand right now, and about sea surface temperature patterns. There's some pretty significant ones right now that I'd like to highlight. From there, we'll go into looking at the subseasonal outlook over the next 4 weeks or so, and then move into the seasonal outlook. What is spring going to look like? And some interesting phenomena around the world. And then finally, we'll talk about the big bear in the room, which is the likely El Nino that we're going to see in summer 2026 and beyond. Now, how strong that El Nino is, it's still a bit up in the air, but it seems that all the models are now converging on it, so it's pretty important to talk about. So, how do we forecast weather beyond 14 days? So, for a 14-day weather forecast, what we use are numerical weather prediction models, which are fundamentally atmosphere models. They are complex models, tens of thousands of lines of code that include a lot of the physics of the atmosphere, including how the atmosphere moves, how it moves light through it. That's the radiation piece, how little particulates exist in it, etc. The atmosphere essentially has no memory after about 14 days. And so what that means is that if your modeling is based just on the atmosphere, you are literally only going to have about 14 days of predictive power. On the other hand, when you use an Earth system model, Earth system models include not only the atmosphere, but also ocean, land, and ice. And these systems have much longer memory than the atmosphere, but it also makes for a much more complex, heavy model. And so these models are used for anything beyond your 14-day weather forecast. So these are the types of models that are used for long-term climate projections, including by the IPCC. And these are also used for all S2S type applications. So subseasonal, seasonal, subdecadal, beyond. This is how we forecast long range weather. Keep in mind that these weather forecasts are not day to day. We can't tell you the particular day that, for example, a typhoon will hit land 6 months from now. On the other hand, we can tell you the probability of typhoons forming over that particular ocean basin and the regions that are at risk, for example. So, if you know how to use these forecasts, they can be really valuable for understanding what is to come in the near future. So, let's look at the fundamentals of the Earth system right now. So, the way that we do that is we look at modes of variability, and I'm going to highlight three of them right now. First of all, the QBO, the quasi-biennial oscillation. Um, this is predictable about a year or two into the future, and this mode is negative. And that is significant because it really sets the stage for how this winter has been evolving. The other important mode here is ENSO, the El Nino Southern Oscillation. And this mode is predictable for about 6 months, maybe a little bit longer. And ENSO has been in neutral conditions with maybe a very, very, very mild La Nina that has been sort of persisting over the tropical Pacific for the past couple of months. But this is not predicted to get much stronger in terms of a La Nina over, the next few months. In fact, over the next few months, it looks like an El Nino is going to be in the cards. So we're going to move into neutral conditions and then likely into an El Nino by this summer. The final piece of the puzzle is the Madden-Julian oscillation because the QBO is in a negative phase. The Madden-Julian oscillation is strong and its teleconnections across the Pacific are strong. The Madden-Julian oscillation is a mode of variability that lives in the tropical Pacific Ocean, not the tropical Pacific close to South America, but the tropical Pacific close to Australia and Oceania and the Indian Basin. And so this mode of variability actually has teleconnections that percolate all over the world, particularly to North and South America. And this mode is predictable up to 30 days out, and usually it gives us some decent subseasonal predictability. So I'll be touching on that. And the phases that we expect the MJO to be going through over the next few weeks include currently it's in a phase 7. It is projected to go into a phase 8 relatively soon and then enter into a phase 1 and 2. And this has implications for precipitation and temperatures around the world, which I will be touching on. The wild card that exists in here, including those modes of variability, are temperatures in the North Pacific Ocean. And I call this a wild card because, like, I don't really have a name for it other than quote unquote the blob, which is something that very large temperature anomalies tend to get called. So this is in the North Pacific Ocean, and I've highlighted both of these. So first of all, there's a small cold blob in the Gulf of Alaska. And then there's this very large warm blob in the Northwest Pacific that we've been observing and predicting since summer of 2025. And both of these, even though they're sort of out in the midst of this, vast ocean, they are important because they help drive the position of the jet stream. So what we do is we keep track of factors like this when we look at the forecast and try to understand why it is telling us what it's telling us. So I'm going to start first of all with the QBO and its implications. Particularly right now, we're in a negative QBO phase. And because of this negative QBO phase, we are prone to polar vortex weakening events. The polar vortex is this column of very cold air that is stuck over the Arctic. And what happens when we get these polar vortex weakening events is that this cold air over the Arctic can then break out into areas that are not the Arctic and cause cold snaps, while at the same time, often the Arctic will see really warm temperatures. And so, what do these events look like? Well, these events can either show up over Siberia, so northern Eurasia, or they can show up over North America. And sometimes we have mixed events where they show up over both locations. And generally, with these polar vortex weakening events, we get something like 1 to 4 weeks of predictability for cold snaps. So, this is what we're going to be going over first. So, right now, this is a view from the stratosphere. The polar vortex currently is highly stretched. So when I say that it's stretched, instead of looking like a nice cone of cold air sitting over the Arctic, instead it is sort of jelly bean shaped. And because it is jelly bean shaped, it tends to drive wave activity from the stratosphere that ends up at the surface and is going to be creating cold snaps. And as I mentioned before, these kinds of events, these stretching events, these disruption events, they can give us 1 to 4 weeks of predictability into major cold snap events. And so that is significant because right now we're looking beyond that usual 7 day or 10 day weather forecast into the future. And the future can be well predicted over these time horizons when we have these weakening events. So currently, we are in the midst of one of these weakening events. And so this weakening event, it looks like just a really canonical pattern where we see warm temperatures over the Arctic, including a blocking pattern over Greenland, and really cold temperatures over Canada and the eastern US. And this is because of Arctic air outflow, essentially because the polar vortex is weak. It is driving wave activity that pushes the jet stream southward. And so this cold air from the Arctic is advected southward, and warm air is advected into the Arctic, creating this kind of very warm Arctic at the same time. The really cool thing is that the MJO is very strong right now. We're in a phase 8, and it is very likely that this MJO is reinforcing this polar vortex weakening pattern. So both of them together are giving rise to this pretty significant event that is going on right now. And so this is what an MJO phase 8 tends to look like. And you can see that it looks very similar to this pattern right here. And by the way, it's an MJO phase 8 teleconnection pattern over North America. Remember, the MJO lives in the Indian Ocean and in the West Pacific. So we can't see it in this figure particularly. So, the really cool thing that we're seeing now, about 3 weeks out, is a winter season warm spell. So we are starting to get into, the time span where we start thinking about like, when is the spring coming? And so often with spring coming, we get a lot of false starts to the spring. And it really does look like we're going to experience one in sort of the first full week of February. So this is February 3rd through 9th that I'm showing here. And so, what is driving this? This is not driven necessarily by the stratosphere. We believe that this is actually, to some extent, sort of the fundamental pattern that is favored by the fact that we have a cold blob currently, cold surface temperature blob that's sitting over the Gulf of Alaska. So that cold sea surface temperature blob helps drive some ridging patterns over the western US. And so this is sort of consistent with, what we're seeing in the temperature. Note also that this week we expect the MJO to be in a phase 1, and we do believe that this is likely reinforcing this pattern with a warm Canada and western US and a cold eastern area region. So this is coming. Now, why do we care about winter warm spells? Because, we've been sitting around talking about cold snaps so often. The reason why we care is it's going to have implications for many sectors. So for hydropower, these kinds of events can drive the start of early runoff, which means that often you're getting a lot of power, a lot of hydropower at the time, perhaps when you don't need it. And by the end of the summer, often you can end up with a shortfall. So that is significant for utilities specifically that rely on hydropower for their energy mix. We also can see reduced agricultural yields if we expect cold weather to resume. And in particular, with this warm spell, we do expect cold weather to resume. This is February. We're not going to expect this, spring to be here already in February. And so what happens is that crops tend to deharden. So buds and shoots tend to deharden. And then when the cold weather resumes, often these are killed off, and this ends up decreasing yields. We also know that infrastructure damage can occur, so we end up with freeze-thaw cycles where we get, damage to major bridges, to power infrastructure, to pipelines, to roads and transportation. So this is an area where events like this can really add to maintenance costs. And furthermore, these early type events can increase the risk for flash flooding from ice jams. And so this is significant, particularly for Canada. So might be something to keep an eye on over the next few weeks as this warm spell plays out. Now, moving on to the spring. So, as I mentioned earlier, mostly we're looking at an early start to the spring. Here I'm looking at the March 2026 forecast, And this is our March 2026 forecast from early December. Just wanting to highlight, like, it really hasn't changed very much. These forecasts don't really bop around that much. A little bit of the spatial pattern has changed just in that, here we might expect a little bit of a colder March over some parts of the Western US, but in general, the US and Europe are going to see an early spring. And Asia as well, Northern Asia. And so there are some regions where we'll get a later spring, and this includes Canada and also likely Alaska. So just something to keep in mind in terms of what that spring outlook looks like. Now, there's some really interesting rainfall patterns that are showing up in the US Southeast and Midwest, which I highlight here. So here I'm looking at the March 2026 and April 2026 forecasts. And so what we see is wetter than usual conditions over the South, and the lower Midwest and the Eastern US. And so, one thing I want to highlight is that we're seeing these kind of 2 months in a row. And note that this is how an event like the flooding at Bonnaroo first started showing up in forecasts. So what we tend to see initially is that we see these periods where the precipitation is forecast to be higher. And then from there, we can sometimes see, for example, oh, this weekly precipitation at week 2 or week 3 is really high. And so sometimes these types of flooding events that are pretty significant can initially show up like these elevated monthly precipitation forecasts. So definitely something to keep an eye on, as something that could be a risk factor for potential flooding. And keep in mind also that this is a region that often experiences flooding, particularly in the springtime. So something to be aware of. We also expect some really drier than usual conditions over Florida and the Gulf Coast. And this is important because Florida does get droughts, even though it seems like the land of water. And it is also prone to wildfires. And so this is just something to keep an eye on in that this region is potentially expecting a shortfall of water. If we move over to Asia, we see that the spring once again looks like it's coming early, and we see that there are elevated temperatures over the Tibetan Plateau projected for February and for March. What this means, once again, is the risk of ice jamming events as ice breaks up in rivers and starts being calved from glaciers up in the Tibetan Plateau. And often in this region, we will see flash floods and associated landslides. And so this year, it does look like we are primed for that sort of activity. So that is something to keep in mind in terms of both lives and livelihoods in this region downstream of the Tibetan Plateau. The blob. So in late spring and early summer, we expect this blob to continue. So this was our forecast issued in early December. This is the forecast now. It hasn't really changed substantially. There is a very slight weakening of the blob, particularly over the Eastern Pacific. But in general, it's still here. Notice that there is this very warm region of SSTs, sea surface temperatures, right off of Baja California. And right now, we're seeing some very interesting tropical typhoon activity in this region. These typhoons are not expected to make landfall, so don't worry about that. But it is very abnormal activity. We usually don't see typhoon formation at this type of time of year. And so it really attests to just how warm and unusual the conditions are over this region at this time. And I mentioned the blob because once again, this blob tends to drive deviations in the jet stream, and this can have downstream consequences for North America, including the US, Alaska, and Canada. One interesting kind of just sort of detail that emerges from the forecast that I'd like to highlight, moving to South America and moving to precipitation, is the fact that we are expecting to see reduced Arabica yields from Colombia over the next year. And this was something that was actually highlighted even in October last year. So since October, we have been, just observing this region and seeing that the precipitation has been significantly higher than normal, expected to be significantly higher than normal. And so what we see in the forecast is that this is forecast to continue. So in October, people were forecasting 10% lower yields. My expectation is that this is going to be potentially even lower, just because of the fact that, we're not really seeing that this excess precipitation is abating. So this is a region to watch out for. These coffee plants in the highlands are very sensitive. They like sort of cool conditions and wet conditions, but not overly wet conditions like most plants. And so often we end up with excess disease and decreased flowering when we get these prolonged periods of precipitation. Finally, let's move forward to looking into summer 2026 and beyond. So, what we think is that in summer 2026, we are likely to get an El Nino. And this is looking more and more likely as each forecast comes in that is incorporating new data. And right now, it looks like, a moderate El Nino, not necessarily a super El Nino, though there are ensemble members that do predict something that looks like that. Chances are that this is not going to necessarily increase to a super El Nino this summer. So it might be something that increases over the following year. Either way, El Nino is really significant and it provides a great way to sort of predict both weather conditions as well as hazards because it has such strong teleconnections all over the planet. And remember, teleconnections are those ways where regional phenomena can affect conditions really far afield. And El Nino, the reason why everyone talks about it is because it has really strong teleconnections all over the globe. So in this figure, this is a figure from NOAA, the Climate Program Office, and what it shows is summer impacts of El Nino. So it shows like where in summer will, and when I say summer, I mean Northern Hemisphere summer, so June, July, August. Where does El Nino usually lead to warmer than usual conditions, and where does it usually lead to wetter than usual conditions? Or in this case, you can see this is mostly brown, so drier than usual conditions. So some things that I would like to highlight. First of all, generally in El Nino, it leads to a weaker South Asian monsoon. And what this means is monsoon onset delays as well as failures and shortfalls in the monsoon. So definitely something to keep track of because, there's a couple billion people that depend on this monsoon happening as expected. And so this will likely have some knock-on impacts. Moreover, we tend to see impacts on typhoons and hurricanes, particularly in El Nino, often is accompanied by a weaker Atlantic hurricane season. However, in terms of the SST patterns over the Atlantic, we'll have to see how those evolve. Currently, they do look not necessarily super warm. So this projection of a weaker Atlantic hurricane season might actually end up being the reality, given that Atlantic SSTs are near normal or maybe even slightly cooler than normal in regions where hurricanes tend to form. On the other hand, El Nino always leads to a stronger Pacific typhoon season because the regions where these Pacific typhoons form is warmer and moister. And so this is definitely something to keep in mind for folks on the east coast of Asia because it is likely that it's going to be a strong season towards the end of 2026. Then we also see major drought events and accompanying wildfires in Australia and Oceania associated with El Nino. We also will see warming and drying over certain parts of the Amazon. And really interestingly, there's some papers that show more severe convective storms over particularly the Great Plains during El Nino years. So there's a lot of effects of El Nino. We could literally have a whole webinar on El Nino, which we probably will because there's so much to talk about. And this is just, something that gives us a lot of predictability into the future. That's why meteorologists get so excited when there's an El Nino, because you're like, wow, I can tell you the future so well because of this. So stay tuned for this. I think it's going to be a really interesting start to 2026. And so that concludes this week's webinar. And if you enjoy these webinars, you can find all of them on YouTube. Usually today's webinar, we will post it with a bit of a delay. And so you'll usually see it come online, I believe, this weekend. But all previous webinars are available. You can scan this QR code if you want to go straight to our YouTube channel. And I want to just highlight what our next webinar will be. So, what I am going to be speaking about is how real world weather events can emerge in forecasts. So, what I'm going to do is go through some very particular case studies around the world where we show what can we know months ahead, what can we know next month, what can we know weeks ahead, what can we know days ahead. And so, how these significant weather events can be anticipated and planned for, and so they don't have to necessarily catch you by surprise. So, I hope you'll join us for that. And so, thank you so much from myself and from Planette and our team. And I will be happy to answer any questions. If you're really interested in our forecasts and what they can tell you about the future and how this might be able to enhance your decision making, please feel free to get in touch. I'm on LinkedIn, and I believe Leo has also shared some contact information within the chat. So thank you so much. Happy to answer a couple of questions before we log off. Okay, that's a great question, Leo. So we have the question of what are the most common ways that organizations can misinterpret long-range forecasts? So one thing I would say that often can happen is that the long-range forecast might look like a nothing burger. And sometimes the reason why it looks like nothing or just climatological conditions is because at that point, the forecast, it's just too early. It doesn't know. And so sometimes people take that as being like, oh, well, there's nothing interesting in the forecast. And then they're upset when, lo and behold, something else pops up in the forecast. And that is actually because maybe you know nothing 3 months out, but maybe at 1 month out, oh, we're actually seeing some predictability. We're actually seeing something show up in the forecast. So this is actually pretty important to keep in mind when you're looking at long range forecasts. A null signal or a, nothing much is happening signal can actually just mean that there's not enough predictability in the system to know at that time horizon. So it's really important to keep that interpretation in mind when you're looking at long range forecasts. All right. Well, we're closing in on 10 a.m. And so thank you so much, all. You know where to find me. And I look forward to seeing you at our next webinar. Take care.